In this video, we'll learn how to apply our knowledge of reference angles and our knowledge of basic trig functions and their ratios, and combine that knowledge together to evaluate trig functions that are bigger than 90 degrees. So let's go ahead and take a look at this first one, sine 240 degrees. Now, anytime we're trying to evaluate a trig function without using a calculator, the first thing I'd want to do is sketch out my angle. So 240 degrees we know is bigger than 180, but less than 270. So we can say that that angle would end up down here in this lower left quadrant, so the third quadrant. And I went that direction to get there. Now, based on what we know from reference angles, 240 degrees is 60 degrees away from our 180. So I could say that angle right there is 60 degrees. But we know something about 60-degree angles. We had a special right triangle with a 60-degree angle, with a 30-degree angle, and a 90-degree angle. And the side lengths on that were 1, 2, and square root of 3. So if I came back over to where I drew my 60-degree angle on the axis system, I can finish off my right triangle and label my sides and angles. So across from 60 degrees is the square root of 3. Across from the 30-degree angle, which would be down here, would be a side length of 1. And across from the 90-degree, or the hypotenuse, is 2. Now, one thing we need to be careful about when we're doing these is, since the 1 on the top of the triangle is coming to the left, I want to make sure it's negative. Since the square root of 3 is coming down, it would also be negative. But going back to our sine function right here, I know sine is the opposite side of the triangle divided by the hypotenuse. Well, if I'm basing that off of my reference angle, the opposite side of the reference angle of 60 here is square root of 3, or negative square root of 3, I should say. And the hypotenuse on here was 2. So that would be the value of sine of 240 degrees. Opposite side of negative square root of 3 divided by the positive hypotenuse of 2. Now, you may look at that and think, well, why isn't the 2 negative since it's coming down? And when we're doing these evaluations of trig functions, the hypotenuse will always be a positive value, regardless of which direction it goes. So let's try a second one here. We want to evaluate the tangent of 150 degrees. So let's go ahead and draw a 150-degree angle. I know that 150 degrees would put me just a little bit short of 180 degrees, going in the positive direction. Now, if I think about reference angles, the reference angle on that would be 30 degrees, because that's how far it is away from 180. So again, if I think about our special triangle here, we have a 30-degree, a 60-degree, a 90-degree, and we can label the sides, the 1, 2, and square root of 3 in the appropriate places. Well, that can be beneficial over here. Let's finish off our triangle with that 30-degree reference angle. I can have a 1 on the left side. I can have a square root of 3 on the bottom, but it's going to be negative because it's coming to the left. And I can put a 2 on the hypotenuse. And then I've got my right angle down here in the lower left. Now, our trig function said we wanted the tangent. Well, tangent, I know, is the opposite side of the reference angle divided by the adjacent side of the reference angle. So if I'm going off of this 30-degree reference, opposite side is 1, adjacent side is negative square root of 3, so that would be the value of tangent of 150 degrees. We located the angle, we drew in our special triangle based on the reference angle, and then evaluated based on the type of trig function that we had. Let's try one more, this time with cosine and also with a negative angle. So negative angles, we need to remember, go the opposite direction from positive angles. So 315 degrees would end up in this upper right quadrant if we're going in the negative direction. And if we look at the distance between 315 and the closest x-axis, which would be 360 degrees, we can see that our reference angle, or what's left over, right here would be 45 degrees. Well, we know something about a 45-degree angle as well. If we think back to our other special triangle, we had a 45, 45, and 90-degree angle. Both of the legs were legs of 1, and the hypotenuse was the square root of 2. Well, let's go ahead and extend our triangle here and draw that in. So now vertical side is 1, the horizontal side is also going to be 1, and then the hypotenuse is square root of 2. Now in these last two problems that we did, we said that the bottom side or the other side were negative because of their direction. We don't have to worry about that in this last problem here because both the horizontal and the vertical side of the triangle are the positive direction, the positive x and the positive y. So we can keep the 1 and 1 as such and not make them negative. Now, when we want to find the cosine we know is the adjacent side to the reference angle divided by the hypotenuse. So based off of our reference angle here, 45, the adjacent side is 1, the hypotenuse is the square root of 2. So that would be the value of the cosine of negative 315 degrees. So on each of these, the key was first graphing our angle, whether it was positive or negative, locating our reference angle, and then based off of that reference, sometimes it was 60, 30, or 45, any of those refer us back to one of our two special triangles. Once we've drawn that triangle in, we can evaluate our trig function based on the ratio that it corresponds with.